correct perspective depends on knowing where eye level is, and eye level and horizon are exactly the same thing. If you can't see the horizon, then you must work out where the horizon would be if you could see it. Now, if you're standing on a level surface and there are people of similar size in front of you, then you will find that their eyes will all connect together with a horizontal line, even if some of them are quite a distance away. That line is eye level. The slight variations that you see are down to the slightly different heights of the different people. So obviously people that are taller than me, their eyes will be above my eye level. People who are smaller than me, their eyes will be below my eye level. Here we can't see the horizon, but eye level will still connect the people as before, assuming the ground is level. The artist uses perspective to create the illusion of depth. There is no true depth to a flat sheet of paper, but we can use perspective to create that illusion of depth, the illusion of the street disappearing into the distance. And this illusion depends largely on what appears to happen to horizontal lines as they recede. If we look at this rectangle, you will see that there are a number of horizontal lines drawn on it. Now, all of these lines are clearly horizontal. Now look at what happens when we create depth by turning the rectangle. You will see that things change. The lines at the top slope downwards and the lines at the bottom slope upwards. You will also see that the lines at the top and bottom have the greater slope, whereas these two lines only slope slightly. Perspective is where receding horizontal lines appear to slope towards eye level as they recede. Now try to remember that single sentence. It is the basis of almost everything to do with perspective. Receding horizontal lines, in other words, horizontal lines moving away from you, appear to slope towards eye level as they recede. And if we continue to turn the rectangle, you will see that the slope becomes greater. Now let's look at what happens when we continue the lines beyond the rectangle. No matter how many lines there are, they will all converge at a single point on eye level. This is the vanishing point, and the vanishing point for horizontal lines is always on eye level. And this single vanishing point is true for any number of horizontal lines as long as they are parallel. This allows us to work out where eye level is even if we can't see the horizon, as long as we have sight of these receding horizontal lines. What we need to do is find a line slightly sloping down and another slightly sloping up, and eye level must be between the two. You may even be fortunate enough to find a line that corresponds exactly to eye level. No matter how simple or complex a building may be, it will have a single vanishing point for any horizontal lines that are parallel to each other. So in this street, for example, a single vanishing point is all that is needed to construct all of the lines in the buildings on both sides of the street. And it's not just buildings. Even on this bus, we can use the same process. And on this train station. The average building will have two sets of parallel horizontal lines simply because the building has both width and depth. There will therefore usually be two vanishing points, one to the right of the building and one to the left. But notice again that both vanishing points are on eye level. It is also important to remember that if you are drawing a building, the vanishing points may not necessarily be on the paper. They could well be, and most often are, beyond the left and right boundaries. Notice that the heads of the people are slightly below eye level. Now this might seem to contradict what I said earlier, but actually the reason is very simple. The road is slightly sloping. It isn't on a true level horizontal surface, and the people in front of me are slightly lower than I am. Therefore, logically, their heads will be slightly lower than my eye level.